So I will start, right?
Yeah.
Great. So welcome everyone. I have the pleasure today to meet you on our local chapters presentation. I'm Veronica, head of local chapters in Omdena. I know these guys and I see their work on an everyday basis, and I'm really proud to share what they did. All local chapters projects are open source and for good causes. So we are always happy to share what we did. We have a lot of going on in Omdena. So if you don't know much about it, feel free to explore our website. We have a lot of great things going on and upcoming. If you wish to join local chapters, you also have the possibility to do so. So if you get excited about what was done, you surely have a lot of possibilities to join similar projects and create other powerful solutions for the better future. Now I want to give the voice to our presenters, and if you have more questions about Omdena or local chapters, in the end, I will for sure answer them. So I give voice to Tariq, and he's the chapter lead of Cologne local chapter from Germany. And now they will present their amazing work.
So thank you so much, Veronica. It's a pleasure to be here, and it has been a pleasure working with you guys, absolutely. And thank you so much for this opportunity to present our projects to everybody. We had a lot of fun doing this project, and today we want to show you what we did and how a few people coming together in an online space can create solutions for big problems of the world. Thanks a lot to Omdena to provide us this platform and all the support and help that Isel and Veronica have provided us, also Harini. So I start by telling you the topic. So we are Omdena Cologne chapter, so Cologne Germany chapter, and we have done a project which is detecting bias in climate reporting in news media. This project was done over 2 months from the beginning of February to the end of April, end of March or April. And this is a real world project walkthrough. So we will be talking about what solution we built for a real world problem. So it's not just about learning or, putting our heads together to understand what's going on in machine learning, but actually solving a problem. So we are joined by our speakers who were also task leaders in the project. So the team is Christine, Anmol, Futse, Steve, Oxte, Alex, Rashmi, and Babak. So they're all here, and some of us will speak, and some of us are here to answer your questions, whatever they may be about different aspects of the project. And before we start, I show you the agenda of the project or of this presentation. First, we talk about climate reporting. Where did it go wrong? And why did we even decide to take on this topic? Then we show you the initial idea for the solution, which will be, Christine will talk about. A little bit about the world of the Samsara of the bias determination framework. Then the pipeline, different aspects of the pipeline, and then we will show you our exciting demo, and then challenges and lessons and what's next for this project. So first have a look at what problem we are trying to address. Ideally, all the news regarding climate change you see in newspapers, written articles, should convey the fact that climate change is real and human activities, largely the release of polluting gases from burning fossil fuels, etc., are the main cause of this climate change. By this point, we have centuries worth of data that proves this point. Similar to the graph you see here, which shows that more than half of the CO2 ever emitted by human activity has been in the last 4 decades. unnatural global warming was already proven to be a potential problem by the 1980s. This is not new news at all. And the link between greenhouse gas emissions and climate change was being discussed by scientists from even the 1800s. And here you see a clipping of the New York Times with its big headline that global warming has begun from the 1980s. Then what went wrong, and why do we still find newspaper articles and TV debates treating the climate crisis as something we don't need to be alarmed about? This campaign to put the larger public in doubt about climate science has been deliberately undertaken by fossil fuel dependent organizations and has been going on ever since global warming was recognized as a fact in the 1980s or 90s. And on the screen, you can see one of the many proofs of this misinformation campaign, which is an internal memo from the American Petroleum Association in the 90s. This deliberate misinformation campaign continues with newspapers like you see in the screenshot, some newspapers which are backed by rich and powerful businessmen that make this problem worse every day. The media coverage of the climate crisis is often biased. As I said, you can see in this screenshot, it's often misleading, inaccurate. And what is the outcome? The outcome is stalled mitigation of the climate emergency in many countries, where its health impacts can be deadlier than cancer. So this is why we thought that there needs to be a technological solution to this huge misinformation and disinformation problem. How do we do that? We do that by providing scientific sources of information, which is key to this pursuit. Since we usually rely on news media to correctly interpret scientific results and get them to us from scientific papers or from experts in an easy way. But what do we do when the media is biased or sold out? The answer is that we get to you the information directly from the scientific sources. So we built this bias detection framework to have a few different elements. So you can see on the screen these different elements, which are claim detection. So first we have a claim, we have to detect something as a climate claim automatically. Then we have scientific verification, which matches the claim detected with the scientific information from credible sources. Then we have stance detection, bias recognition and scoring, and also extending all of this to other languages. So over the next few slides, and our speakers will communicate with you and show you what we were able to accomplish and what we want to accomplish. And so first, I hand over to Christine, who will comment on the initial idea of the bias detection framework before we discuss the technical parts of the project. So Christine, all yours.
Thank you. The initial idea of the project was exactly what the topic suggests: to detect bias in written articles dealing with the topic of climate change. There are many kinds of biases that present themselves in news articles, like slant, sensationalism, opinions presented as fact, negativity bias. But one that is particularly interesting is the idea of false balance. Essentially, it means that we're presenting the whole story when in fact the balance isn't correct. In this graphic here, we see the two types of medias. We have the media that's shared among climate scientists and the one that's on Fox News. And then there is a definite difference in opinion. I mean, there's a 97% consensus among climate scientists that human-caused global warming is responsible for the climate crisis. And 69% of the media that's available on various news networks deny this fact in the name of giving equal or more space to unscientific viewpoints. But what does this all mean? Well, to detect biases and other types of misleading information, we thought we could combine information quantitatively into a bias score using words, which should then be displayed to the user along with correct sources of information and a user-friendly interface. Here is a graphic to convey the initial idea of the pipeline. As you can see, we have the newsworthy article, or the news article, the trustworthy AI. You wonder if it's trustworthy. I mean, the news article, the AI is great. It's going to give us a bias score by combining all the words quantitatively. Anyway, next, please. In this type of project, what we did is we created a way to verify scientific claims, and that gives the user information. It's not complete verification. It's dependent on our tool, which is linked to a database. And so, but we can give the user information that helps them make a better decision about the information that they're receiving. And so then as a result, we ended up addressing two types of media biases: unsupported claims and omission of source. Now, what happens is we built a scientific verification system that cross-matches the climate-related claims in the media against information from the articles written and published by scientists, which is information that the common person usually doesn't read directly. And we will now show you how the pipeline works, for which I will hand over to Amul.
Yeah, thank you, Christine. So now I'll talk about claim detection, which is the first major step in our scientific verification pipeline. So our primary aim in this project was to build a fact-checking mechanism for claims in climate-related news articles. And for that, the first part is to detect claims. So here we start with a climate-related article. And the first step in our pipeline is text extraction, which simply put implies that we extract only the text from the news article, and we ignore all the other elements of the article like images, links, etc. Then after getting only the text, the next step we perform is co-reference resolution. So this is a process which is performed on the text to find all the expressions or sets of words that refer to the same entity. So in the above example, I voted for Nader because he was most aligned with my values, she said. Here, Nader and he refer to the same entity, and I, my, and she refer to the same entity. So after finding these, we replace the pronouns, which are basically the indirect references to the entity, with the nouns, which are direct references to the entity. So like we can replace he with Nader, and then resolving such co-references is important to give the subsequent parts of the pipeline more context in the cases where entities are referred to in an indirect manner. The third step we have is text splitting, wherein we split the co-referenced resolved text into individual sentences or pieces of text, not just based on punctuation, but also considering the context of the text around it. And this is required so that the sentences or pieces of text can be processed individually moving forward in our pipeline. Next, we check whether the piece of text is directly related to the topic of climate or not. And so this step of our application predicts 0, that is no, that is a class no, for a sentence which is not climate related, like the inflation rate soared, causing prices to skyrocket. So this sentence is not directly related to the topic of climate. And it can also predict a class 1, that is yes, for an example like rising temperatures threaten ecosystems. So this sentence is directly related to climate. And after this categorization of the text pieces, we'll filter out those which aren't related to climate and only include those which are related to climate moving ahead. Coming on to the final step of our claim detection pipeline, we determine whether the piece of text is a check-worthy claim or not, because only the ones that are will be fact-checked. So this step in our application categorizes the text piece as a non-check-worthy sentence, like, for example, climate change is the biggest challenge of the century. This is non-check-worthy. Or a check-worthy factual sentence, like the example, urban acidification threatens marine ecosystems and coral reefs. So a non-check-worthy sentence can either be an unimportant factual sentence or a non-factual sentence. But in either case, it is not check-worthy. Now I hand over to my colleague Steve, who will talk more about what we do after getting these check-worthy claims.
Thank you, Anmol. Okay, so Anmol just described how we acquire a claim from a news article and fix it up so that it is most useful for the next step, which is scientific verification. So we have the claim, we need to verify it against scientific evidence. So how do we do that? Presumably there's some AI happening in there, and we come out with an answer about whether the claim is supported or refuted by scientific evidence, or stated similarly, whether the evidence supports or refutes the claim, which I think is the nomenclature we actually see in the extension that we built. All right, so let's talk about the actual steps. Retrieving relevant evidence. The first thing we did was go and look in, there are repositories for scientific evidence. We needed just the climate science, and there are repositories that let you search that way, and that's what we did. So we retrieved a whole corpus of scientific abstracts that were related to climate. And we pre-encode those for semantic searching. So that we can, you'll see in a later step, we want to pick only relevant evidence from climate science. And this is the first step to doing that. We encode everything and we store it in a database. Having done that, we now can encode any incoming claim. And we encode that claim the exact same way. And we use that encoding to search the database and retrieve only the evidence and scientific abstracts that are relevant to the claim. Whatever the claim is talking about, we'll find the same kinds of documents in our database. So now we have a claim and a select set of evidences. It's time to actually classify these, verify them. We do this one of two ways, and we have two models available to us. One of them compares on a sentence-by-sentence basis. Recall, the claim comes to us as a sentence, the evidence comes to us as a complete abstract from a scientific paper. One of these models compares each sentence in those abstracts to the claim sentence to try to classify it as whether it's supported or refuted. As you might guess, we lose a little bit of context from a scientific abstract by looking at just individual sentences. And it would be nice if we had a way of comparing the claim to the entire abstract. It turns out we do have such a model available. So we have a second way of doing this comparison. And we compare the claim to the entire abstract at one time. The sentence by sentence is a faster check, but it loses context. The full text check is slower, but it includes the context from the entire abstract. So we figure that each of these have their best uses. In either case, what we come out with at the end is some kind of classification for this claim against the evidence we selected about whether that evidence supports or refutes the claim. This happens on a per evidence basis. So it might be that we end up with a mixed bag. That is possible. Some scientific evidence, supports or refutes to different degrees. And of course, there's always the possibility that no determination can be made. We allow for that. We hope it doesn't happen. We hope to actually come back with a supports or refutes. That's it. That's how we do the scientific verification. That's not the end of our pipeline. We do also some other analysis. And for that, I'm going to hand over to Futse to talk about stance detection.
Thank you very much, Steve. Now that we hope that you guys have understood what scientific verification is, it's important to note that one other important aspect is to verify the author's point of view regarding a specific information. So this is what motivated our interest in stance detection. So stance detection here is simplified in the following image. It is simply the process of detecting automatically the point of view of an author of a text, whether they opposes a specific target or they are in favor of such a specific target. Because we know that today our source of information are mainly news, to actually know if the information you're actually taking as fact is not biased, it's important to help you detect whether the person that is writing the information is not transmitting his own bias in the information. So to briefly illustrate how this aspect is, we kind of summarized it in the following image. So our main goal is to provide a platform that is simple enough that someone could take a piece of information, like from a news, and our model try to, first of all, detect whether the information is climate related or not. If the information is climate related, our model now tries to classify whether we have here a positive stance or a negative stance. A positive stance here means that the individual is in favor of a specific target. And our target here is to, for example, whether human activities impact global warming or not. So if a piece of text kind of agrees with this, we are going to have a prediction as a positive prediction. And if it is against it, we get a negative stance. So now I'm going to hand over my colleague, Alex, who will walk you through the exciting part where he's gonna show the deployment and application of it. Thanks.
Thanks, Futse. Can you, yeah, cool. All right, so the system in the end consists of several components. There are two user-facing applications. One of them is the web application and the other is a Chrome extension. And both call the API that we have in front of the database of scientific paper abstracts that are climate impact related. So, whoops, yeah, cool. So yeah, and this database, we use it as a source of evidence for the scientific verification task. And the web application also allows to perform the global warming stance detection task. Web application and the API are both deployed on a Google Cloud. Also, we have a homepage with the links to the sources, and it's deployed on Render. And the idea is of the two applications come from the fact that the Chrome application is directed more to the end users or people who read the article. And the web application is directed to developers. And well, the reason to do that is that it's still a work in progress. We're still not very happy with the predictions that are made, so we're working on it, right? So okay, now I will steal presentation from Parit, and okay, let me share. All right, hopefully you can see my screen. Okay, so we will start with the web application, and you can see here that there are two options available. First of them is scientific verification, and the other one is global warming stance detection. So we will start with the scientific verification. Now I will close it to get more space. So here what we see is a text area where you can either put the text that you want to verify or paste a link to a media article. And then there are many options. As I said, it's more for the developers, so there are many options that can be tuned. I won't go through them now, but just to show it to you. And then the choice of the model that Steve was just talking about. Okay, so now what I do is I put some text. Well, in fact, I will just use the text that we have here. CO2 is not the cause of our current current warming trend and press verify. And here below we see the predictions. So it all first starts with the claim that we put. And so if we had a longer text that consists of several sentences, we would have had several such blocks. And then what comes next are the blocks of evidences. So one evidence block starts with the label that was given by the selected model, which in this case is reputes, then the probability of the prediction, and then the information about the actual evidence, article title, the year of publishing, rationale, which is a phrase from the article abstract, and then the article citation count. And in this case, we see here, especially CO2 and main drivers of recent warming. Okay, I think that's all about the scientific verification. Now we'll go to stance detection, and for that I will actually paste a link to an article. So from the link we see that study disputes Earth climate emergency. So we expect it to be negative towards global warming stance, towards global warming existence. And then, okay, there is just we'll press a detect button and wait for a bit for the predictions to appear. And well, you can see that it's the sentences are mostly predicted to disagree with the existence of global warming. All right, so that's all from the side of the wrap up. Now I will pass a word to Octay that will show you the Chrome extension.
All right, thank you, Alex. So as Alex already mentioned that we have built two front-end solutions, and now I want to provide a quick demo into the second solution, which is a Chrome extension. Before I jump to the demo, I just want to highlight that the main goal of building this browser Chrome extension was that we wanted to provide our end users the best possible user experience and user interface while they're engaging with news article related to climate change. So let's start with the demo. So hopefully you can see my screen. So I just took a news article. I just took a news article from Washington Post, also relates to climate. And let's say I'm interested in this part of the news article, which I want to analyze whether it contains a claim or not. And in order to start the extension, we need to mark the part of the news article which we are interested in and want to analyze. And once we have that, we can go to the icon, to the Chrome extension icon, and then click. And here we can see the text box, which just shows the marked text. And then we have the option to start highlighting claims, which basically makes two API calls. One in order to split the text into sentences, and then make another API call to check each sentence whether it contains a claim or not, and then only highlight the sentences which are claims. So let's start. And see how many claims we get. So here you can see now, like we have 3 claims. Like we marked 4 sentences, but no, it just contains 3 claims. And in the extension itself, you see the claims highlighted in yellow, but also within the news article, you also see each claim highlighted in yellow in this case. And we also have the opportunity, like also Alex showcased in the Streamlit app, to verify each claim against phrases from scientific paper abstracts. And so let's start the verification. And then here we have more output, like we have the article title. For each claim, we have the article title, we have the rationale, we have the label, whether it supports or refuses. So those who want to go into the details, they can check out and even also go to the scientific paper and yeah, check it out for more details. So that's it from my side. Thank you.
Thank you, Akshay. So we will put up the main presentation again. Okay. All right. So you saw the different parts of the pipeline, and you also saw the exciting product demo. So now you see that we can pick up a climate text automatically from a media article or or through selection. And you can put it into our system, and the system will tell you whether there is some related text in a scientific article that supports or refutes the claim. Perfect. So let's move on to start wrapping up. We, of course, had a lot of challenges and lessons during this project. And some of the challenges were something like, how do we customize publicly available data sets? So we had, for example, data sets that we wanted to use to train our model to detect check-worthy claims, as Anmol explained. We were also hoping to use customized data sets for to train the scientific verification model. But since this was a short project, we ended up using already available data sets and models. But for the future, we kind of have a roadmap of how we can, also develop customized data sets. The other challenge that we had was, how do we detect other kinds of biases? Since we told you in the beginning that this is supposed to be a bias scoring system. But for that, we have to detect many different kinds of biases. If you'd like to know what these biases are, Christine can explain them to you. And then there is challenge 3. How do we make structured climate data comparable to enable scientific verification? Not all the data that is scientifically verified and factual is available in scientific papers as text. There is a lot of data that we have in data banks, in graphs, in plots, that now we should use to directly derive conclusions from and compare it with climate claims. And of course, a picture is worth 1,000 words. Some more challenges and lessons which were a bit more technical were we learned that we should think of computational resources needed for large language models before initiating NLP projects, GPUs and whatnot. We need to definitely catch up with generative models. ChatGPT has been the rage in the last few months, and while we were doing the project, things rushed past so quickly, and we need to catch up with all of that to see how we can extend our functionalities. Then we also had some project management lessons, which is useful for all project managers in Omdena local chapters. Definitely, we should organize projects using tools like Kanban boards, where breaking down the project into easy chunks early on helps many participants who miss out due to the mess of conversations in Slack. And finally, what is next? This is not it. You saw the Samsara, or the world of our claim bias verification, bias scoring system, or scientific verification pipeline. We did deal already with claim detection, scientific verification, and stance detection. And we did also detect certain kinds of biases, but not all of them. So eventually what we want to do is combine, complete this task, combine all of the different kind of biases into a final bias score which will show you how biased media article might be. And of course, we also want to extend it to other languages like German, Hindi, Tamil, whatnot, Japanese. All the people everywhere deserve to know what real climate science is. With these the challenges that we already envisioned, we also found more that we could address, like how do we track cultural bias, climate action, and policy, which are a bit more subjective. And the ultimate goal of anything we build here is, can we nudge our grandparents to use this system? In the end, if all the news we are getting is from biased channels or WhatsApp, that makes for a very bad audience of people who are going to decide the future of our planet based on information that is not reliable. We need people to know what's the truth. We need people to be able to access this scientific information easily, and it's not just existing to just be confined to these elite journals. So we will have a part 2 in a few months, and therefore this is also a call to action for all of you. Please support this project, and please join us if you can, and if you are passionate about this challenge, to extend the functionality and make this even better. And with that, we come to the end of this presentation. A big thank you to all of our collaborators. You can see the names here with the names of the presenters and task leaders highlighted. Apart from that, apart from our amazing collaborators who were not only really great, I mean, we were all together, not necessarily experts in NLP from the beginning, but some of us did become experts. Some of us learned a lot from experts. All of us contributed in some or the other way. There are a lot of things we couldn't show you today, which were equally amazing. So we will hope to roll them out in the future. And we also would like to thank our mentors, Rosanna, Vincent, Vitura, and briefly we also had Mario to give us some advice about these things. And so this is a big celebration of the amazing community that this is, and the amazing feeling we have getting together, solving problems together, and working on what you're passionate about. So with that, I thank you all for coming today. Now we will hand over back to the moderators and take your questions. Thank you.
Thank you so much, team. And it's so impressive. Like, as many of you may not know, local chapters is mostly with beginners, and it's just like trying and learning and failing and trying again. So it's so impressive. And I think what I want to add also is that we are planning to build something like open source tools library of local chapters. So Omdena will offer this place that you may check what local chapters build and probably use them in some time. So yeah, again, thank you. And now it's the time for the Q&A session.
Yeah, thank you, Veronica. It was a great presentation and it was really helpful. We really got good feedback, great feedback from the live as well. I just want to share that. And we have people from all around the world as expected, like Armenia, India, Egypt, Vietnam, Thailand. And these are just a couple of them that I saw. Toronto, yeah, Michigan, great. Pakistan, I'm seeing like every country in the world. So I am Isa, by the way, marketing manager in Omdena. I will just walk you through the Q&A session. So we got some questions, but feel free to ask them right now as well in the comments so that we can answer them. So this is the perfect opportunity for to ask questions because the team members are here. They will directly answer your questions. They're the heroes of the project. They will just, tell their experiences directly right now. Firstly, I have some questions for Veronica about local chapters. So what are local chapters exactly? Like how many you have, in which countries, what kind of projects are you executing? Like
okay. Yeah, sure. I will be very happy to share that. So local chapters is an initiative to bring education and a safe space for learning in fields of AI, data science, and also lately more and more technology in a broad sense. And the chapter leads, we have now around 200 chapter leads, and we are trying to grow it more and more, support them more and more. And the projects that we are doing with them are always initiated with their own interests. So there's lots of freedom in the role. So they can either build on the top what we already built in local chapters, that we have more than 200 projects already that are open source, or you can completely invent your own idea if it's in the truth and it's good. You can build it with local chapters. And then we have collaborators from around the world that are a mix of beginners and advanced people. And always it's a very interesting energy, very unique atmosphere and community, making friends and momentum, because mostly these projects are very short, around 4, 6, maximum 8 weeks. And then great things happen like this one. And you can explore these opportunities and also other Omdena opportunities on our website. Then there is also the part that is called AI Innovation Challenges. And these are for more advanced people, but it's also a great plan if you feel that you have already enough knowledge to, and the time, it's also a bigger time commitment. And then the third part is top talent projects that are even more advanced projects, but you need to be already committed a lot with our community and projects. Feel free to explore that on our website.
Great.
And
I also shared I also shared some useful links in the comments. So you can also check out our website for local chapters and upcoming projects. There is a related question as well. You talked about chapter leads. What are chapter leads exactly, what they do, like to summarize a little bit, and how someone can become a chapter lead?
Yeah, sure. So chapter leads are essentially people who build their community in their local area. They can be multiple leads in a region or even a city, and they initiate the projects within local chapters. Then they can also have a co-lead if you think that you have friends that you want to do it with. That's also an option. And we have a booklet and a page that is an information page. And if you feel like it's something for you, you can apply the form and then we will take it forward from there. I would love to get to know you better and create some projects.
Great. Thank you so much, Veronica. I'm just checking if we have any more questions to you. No, I think we can move on with the team as well. Thank you so much.
Thank you.
So someone also asked that if the meeting is being recorded. Yes, it will automatically post it on LinkedIn, YouTube, and Facebook just after the meeting. So you can, check the whole presentation if you missed some part of it. I have some questions to the team as well. So I want to ask maybe Parit, since you are the chapter lead, how was the profile of the team? Like, did you have any beginners, experienced people, and how was the dynamic between those like team members?
Great, thanks for the question. The profile of the team was very diverse indeed. we had people from all over the world, literally all over the world. We had a lot of problems organizing meetings because of this, because on the one hand, we had people from, from the West Coast of the United States. On the other hand, we had people from Korea. So it was very hard to find a meeting spot that suited everyone. But eventually we solved the problem. And of course, yeah, there were people. I mean, I would say there are different kinds of things we can think about here. One is the skill level, which was varied. By skills, I mean not just machine learning skills. By skills, I mean everything. How to read newspapers could be a skill. We had also some people who were, experts in mathematics, sociology, like Christine herself here. We had people having expertise in maths. So we had many different kinds of people who could contribute in their own way to the project, and they indeed did. And in terms of initiative, we had also people who were talking and discussing from the first day on, and some people who were silent heroes who showed up in the later parts of the project with amazing work. So it was kind of a mixture, as it already always is in an Omdena project. And the dynamic was, I would say, infectious. There was not one day in the whole project I did not open my Slack and not expect an interesting conversation. Every day I was learning something personally, and probably also other members of the team. And everybody was friendly. We were all clear on the fact that, we were respectful of each other, of how we had to address each other and talk to each other. So it was all in all very nice, productive. You could just go on the Slack and just have a nice time of ideas, I would say.
That's great. So that's why I think we recommend these challenges to everyone, not just for the technical and learning reasons, but also like friendship and the dynamic. And we also, I think, Omdena collaborators mostly learn from each other. So you actually teach each other as well. That's why I think it makes it more special and more like a playground as well.
Absolutely.
Yeah, and it's also like there are different cultures. You also learn about different cultures, how they see this particular topic, how did they get education in their own system as well. So I think it's really great. It's really good to hear and really encouraging, of course, for our audience as well. So I will continue with the questions. I think Ayon Roy asked a question. He says that he wanted to understand the source of data, which was done to help classify whether it's climate related or not. And similarly for checkworthy claims, how do you make sure it's checkworthy? And he also said that afterwards, got it, it's from the scientific literature abstracts. Wanted to know if there are ready-made data sets for this, or the data set was made by the team for the specific great use case. I don't know if it's a long expression, but did you understand? Did you get
yes,
it?
Yes, and I can also repeat it. So I would like that this question, I think Alex would be perfect to answer one part of the question, and then the other part would go to Anmol. If you like, Alex, I can repeat a bit of it, or you probably understood what it was, right?
Yeah, sure. I think I got it. So first of all, the abstracts were used for especially scientific verification task. So the abstract is a database, and the climate relatedness detection and claim detection, these are two separate models. So I will talk about the abstract database now. So it was collected by us, and we used publicly available databases, which is OpenAlex and Semantic Scholar for that. And then the abstracts were indexed in a database in a vector database to then perform semantic search to retrieve the most relevant abstracts for the input claim. So that is the part of the retrieval of the evidence for the claim. And then to get this claim, probably we should have started answering the other way around, because you start kind of with separating text into sentences and then detecting if it's a claim and detecting if it's a climate related sentence. So for that, Anmol, the floor is yours.
Yeah, so to answer the first part of Ayon's question, the dataset we use for detecting whether a sentence is climate related or not is called Climatext, and it is openly available. It's basically a dataset for sentence-based climate change topic detection. So it consists of data from different sources, like mainly it's Wikipedia, but it also has like data from US Securities and Exchange Commission, and also other sentences extracted from the web. And to answer your second part, the data set we used for the detecting check-worthy claims, that data set is called Claim Buster dataset, and it is a benchmark dataset which consists of annotated statements extracted from US general election presidential debates. So it basically has a sentence spoken by a debate participant as a text, and then there'll be a label which can either be 3 classes or 2 classes. In case of 3 classes, it can be a check-worthy factual sentence, an unimportant factual sentence, or a non-factual sentence. And in cases of 2 classes, it's simple. Either the sentence is check-worthy factual or it is a non-check-worthy sentence. Yeah.
So just to clarify here, thank you for the amazing explanations, team. We, especially with regards to claim detection, we actually did a lot more work than we finally implemented. So Anmol led this task, and we developed a few models as he explained. But in the end, what went into the Streamlit app and also the Chrome extension, which we will make available to you soon, that is very limited. So we only use the best possible options. And actually, in reality, we had 3-4 different models ready to deploy. But of course, we had to also verify whether the model performance was good and how to evaluate them in the end. So yeah, what you see in the final product is a very filtered down version of what was going on in the background. Yeah.
Thanks, everyone. I'll continue with the others. Yeah, there's a question from Jen. They say, awesome. Does the system also work on news articles that are in the form of an interview or debate?
Yes, it's not suited for that. I think I would still again ask Alex to take this answer. Yeah.
Sure. It works, like it can be applied to any text, but the actual scientific verification part, it's supposed to verify the scientific facts that you can encounter in the scientific papers abstracts. So it's a special type of information. So in case that the debate text or any text contains this, it should be successfully verified. And so it doesn't really depend on the format of the text. It's just the what's inside, let's say.
This aspect is different for stance detection, because there you can have different kinds of styles of language. I think Futse can elaborate on that a little bit. Futse?
Sorry, what my battery was low. What do you want me to clarify?
Sorry, yeah. the aspect that whether it could our system could be used on different kinds of languages, for example, interviews in media articles or so. How does it fare for stance detection? What kind of specific language do we look for when we apply our model to the media articles?
Yeah, I think that for stance detection, it should also be capable to detect, because when we are in a debate, for example, it's more of your sharing an opinion about something. And so the text is not having a fixed format, like the format is expressing what you are trying to convey, and we can by then detect whether it's biased or not. In stance detection, where we can be tricky, the detection is when we have a specific format, so it's kind of neutral in terms of someone's opinion, the way the message is served. It has a specific format, and in that sense, you cannot really get the stance of it. Is that clear?
Yes, and I think also we tried some experiments with tweets, for example, but it was clear in the end that we have to focus on models that can detect a specific kind of language, which is media article language.
Mm.
Yeah.
Because the tweet was in more of the sense like a conversation. So that's why in some part of the literature, it was advised to couple it with sentiment analysis to actually boost the model to be able to detect the stance better.
Yep. Thank you, Fateh. Back to you, Isabel.
Okay, I'll just ask a question about stance detection then. What challenges or obstacles have you encountered in performing stance detection, and how are you addressing them? Maybe Jose would like to answer, no?
Okay, I think Alex and I maybe, so I will say something and Alex could back it up, because specifically in this project, what we used was an already existing model, and also most of the data exists. So I think that most of the challenges could also come from like getting the label data set with which you could train your model, and also some of the challenges with kind of coupling the extra types of information you have in the different types of text, whereas are not that straightforward, like, because even in the labeling, you have the human bias that could also be implemented in the labeling of the stance detection. So there is that challenge where you need to get experts that will label the data, and you use it, and that's quite challenging because it's not obvious. And even amongst the expert, you could still have diverse opinion, like as to where, and maybe Alex could back it up in terms of the implementation part, because he worked more on it. He can know some other pertinent challenges.
Well, on the making it like available for predictions, as Futsa said, we use the available model from one of the publications on global warming stance detection, and but it is a developer model, so it wasn't like as, for example, as easy to take a Hugging Face model and you just get the predictions like in a couple of lines of code. So just to use this model, you needed to there were some technical difficulties to achieve that. So.
Thank you. Should I move on? Yeah.
Yes, please.
Okay.
Sure.
There's also a question about models as well. What kind of language models did you use? And is ChatGPT one of them?
Okay, yes. Then I think for the best overview would be with Steve. So Steve, if you'd like to take over.
Sure. We explored quite a few variations on some natural language processing or NLP models The current state of the art in these are all transformer based. I'm going to be using some technical terms. If you can, there's a lot of information on the web about these, or you can, ask us for clarification later. But transformer models are built specifically to deal with natural language processing, and portions of them have been extracted out of the bigger transformer model and used for various purposes. We ended up using what is known as BERT, B-E-R-T. I'm going to butcher the actual acronym, but it's bidirectionally encoded representations from transformers. And that is what we've been using for encoding the text for scientific verification. Those models are deterministic. If you feed a particular text in, you get the same vector out every single time after it's been trained. And that was useful to us, and lots of people have been using it this way. We also looked briefly at some of the GPT models, which stands for, I'm going to forget this one now. Someone help me. Generative, I can't remember. Vidura, you know what this is. What's the P in GPT?
Predictive.
Thank you. Generative predictive transformers. And the keyword there is generative. One of the things, if you've been tracking any of the buzz around ChatGPT in particular, is it is non-deterministic. You can give a prompt to ChatGPT or any GPT model and not necessarily get the same response back, which, for a system that's supposed to be verifying scientific facts could be viewed as problematic, and we kind of viewed it that way. The other aspect that kind of made us shy away from it initially is, I love this term, GPT models are prone to something called hallucination, where they make stuff up. It's a statistical process to complete a prompt based on what it knows about how language is constructed, which explains why it could produce something different each time, and sometimes makes up things that don't make sense. For those reasons, we chose to avoid GPT this time around. However, I think Parit mentioned at the very beginning, literally 2 weeks after we completed our project, there were a flood of papers published where people had done something called prompt engineering. That may be a term you're starting to see. Prompt engineering with GPT models, where you give it enough current background information and then ask your question. And it significantly reduces hallucination and also aids a lot the determinism, and you ask it to focus on the information you gave it, not just everything it ever read on the web. And when Parit mentioned at the end of our presentation, we need to catch up now with generative models, that's kind of what he's describing. I think our next project would definitely be looking at how do we, as a smaller project, start doing prompt engineering with GPT models and evaluate their performance and see whether they get us any better answers, say, than the traditional approach, which is the one we took.
Very well, thank you.
If I may add one point, so here we know what's the source of the verification. It's scientific articles, and as you know, the model that stands behind ChatGPT is a large language model. So it was trained on enormous data, which we don't know. Well, we know that it's all the internet rather than only scientific articles. So it can be that it gives you the same bias that we have in the article. So that's an important thing with the generative models.
Yeah, thanks a lot, guys. I would just like to add a short point here that since we're talking about models, it's not just about models that evaluate text. It was, like I mentioned, we also tried our hand on some of the structured data, and I think Rashmi might have a short point on it.
Yeah, sure. So the whole point was that the article could be not necessarily in a text format, but could be an image, or which is equally misleading, or it could be in a tabular format. So we tried to see if there is some way we can also verify the text which is in tabular format, for which we explored some models from which are available from Google's Toto dataset. Basically, it converts the tabular dataset. So if you give like some certain column or certain row as an input, then it creates a sentence from that particular row and column information, and then this information can be verified. So that's something also what we explored in unstructured data set. And this, so we could only explore the tabular form for this project, but going forward, other sources can also be included here.
Thank you. So just to not confuse you guys, what we did end up using is ClimateBird and Multiverse, and everything else we are sharing with you are things that we tried and we want to extend and work with in the future also. Yeah.
So let's say stay tuned, everyone, for your next project with the same team or like others as well. We'll see you. I'm not saying goodbye yet. I have 2 more questions. So yeah, I will get 2 more questions. And the first one is from Madoma. They say that what are the worst false negatives and positives you have encountered? How can the project be improved in this regard?
Fareed, I can take a portion of that, and I think Alex might be able to add to it as well. In terms of worst false negatives and positives, one of the key insights that we learned, some of us as beginners, and I'm sure the experts in the team, probably sat there knowingly saying they're going to discover this soon enough for themselves. A lot of these models are not. We throw around the word semantic encoding a lot. And that is useful in a very narrow sense of the word for finding similarity of topic with a different corpus. It doesn't really encode what does this sentence mean. And that was one of the challenges we had to kind of face up to. That is a, I don't know if it's a flaw or a failing, but these models just haven't been trained that way. So that's one way that we could have gotten some wrong answers, is it doesn't really understand the language. I would say the most important one, though, and this is something that Alex can expand on as well. When you do a sentence by sentence comparison, you take a claim and you take one sentence from an abstract. For anyone who's ever read a scientific abstract, you know that some of that is scene setting. It's setting the frame, and they often will refer to a counter paper that they are in the middle of countering with this, with their new paper. So they'll put a sentence in the abstract that says something counter to what this paper is actually about to show. In those cases, we get back a false negative or false positive. And that is why we were, really interested in finding a model that would compare the claim to the entire abstract at once to kind of help avoid that problem. And I think that's what Multiverse did. But I'm going to let Alex and other people on the team give their perspective on that as well.
Yeah, I'm not sure. Just to clarify, the whole pipeline consists of several models. So there were false positives or incorrect predictions, let's say, on all the in all the models. Like, for example, the model that we use for climate text verification. Well, to be honest, we just took them as it is. And for example, the model for claim detection, as Anmol already mentioned, it was trained on politics related text. So obviously it gives us some incorrect predictions, and the way to cure this is actually getting the data set of scientific claims rather than this, but it was just the first approximation. And then, yeah, like with the sentence by sentence models, we were getting lots of incorrect predictions, mainly I would say because the context gets lost. So I don't know if anyone wants to add anything.
Yeah, I can add one point here, specifically with respect to claim detection. So as I said, if we are talking about binary classification, in this case, 0 represents a non-check-worthy sentence and 1 represents a check-worthy factual sentence. So in any model is, no model is perfect, and like our model also predicted false positives and false negatives. But here we need to decide like which one is more important for us to reduce. So false negative in this case is more important for us to reduce, because false negative implies that the sentence is actually check worthy, but the model is predicting it as non-check worthy, and so it won't, that sentence will not be fact checked ahead, and we can lose out on a sentence. So for tackling this, what we did was we built a classification model, and then after building the model, we get the probability for each sentence, which ranges from 0 to 1, and it indicates whether the sentence is a check-worthy factual sentence. So there's a technique known as thresholding. You can Google it, which is used in machine learning. So you actually tweak the threshold in such a way that the false negative rate reduces, the number of false negatives reduce, and the false negative rate reduces. So for that, the default threshold is always 0.5, and we reduce it. And the threshold which we found most, the best threshold in our case, which gave us a good balance of low false negative rate as well as good macro F1 score, was a threshold of 0.4. Yeah.
Thanks a lot, guys.
Thank you. So I will just ask the last question then, and we will say our goodbyes. So can you see this model being used in the real world, in which setting it can be used and by whom? Like, do you have any, predictions or like goals?
Yeah, I would ask two of our team members to pitch in here. So one, I think Octave would be definitely interested in addressing this question. And then I think we can move to Christine. Yeah, Octave, please.
So if it's regarding the Chrome extension, like regarding deployment, right now it's running on my or on all local machines, because we didn't deploy mostly regarding performance and security topics. Because in order to deploy a Chrome extension on the web store, you need to fulfill several security requirements, and the main focus within the first phase of the project was like building the MVP from the technical point of view. So in the second phase, we will definitely focus on deploying, I would say, at least one of the front-end solutions. So like maybe Alex can add the other one, like the Streamlit, it's already deployed. So everyone can go and check out and engage with all the work that we did.
Yeah, nothing to add. Yeah, it's available, well, only for, again, limited amount, but for the time being, it's available to everyone.
Great. And just to expand a little bit on the aspect of where bias detection and studies of bias are useful, since we did build a scientific verification system that at least shows you, as Christine explained, where sources are omitted, where we have kind of false balance. So Christine, maybe you could expand a bit on where this kind of a bias recognition system would be useful, because you did a lot of research on it. So what would be your thoughts on it?
Thank you. I think that if you can give somebody a tool to help them understand the text a little bit better than what they have on their own, you can help them make a better informed decision about how they're going to use that information, about whether it's buying a product, whether it's considering taking a vacation, or, some type of, environmental campaign that your company might be on. It's just interesting to find out all the information and to know that. I think in the future, we were thinking about developing our model to help users understand different types of bias, like slant, negativity bias, opinions presented as facts. And, for that, Rashmi had Rashmi did this great presentation about the newsroom and just gave me a bunch of ideas on, how in the future maybe we could develop our AI to recognize these different things. And then our bias score would be broken down in terms of different bias, which would give the user even a better idea of what type of biases may exist in the article. Because whether we know it or not, we make a lot of decisions based on bias, and it's not always negative. I mean, if something smells bad, there's a reason for that. Maybe the food's bad and you shouldn't eat it. If the news smells bad, then, maybe take a second glance at it. Try one of our tools. The Streamlit app is available. So I'm just super excited to be a part of all this AI creation.
Perfect. And I think that's the best note to end on. And also, please remember, we have to get this tool to your grandparents. Nothing else matters. But yeah, more seriously, the more people use it, the more people are interested in gathering and dealing in factual knowledge and being aware, as Christine said, about what they're consuming and finding out if it smells good or bad. I think we will have a winner.
Yeah, very well said. Thank you so much, guys. And I will just ask Parit to share the useful links or GitHub repo or anything that you can that you see as useful in the comments of the live event. So I think it will be really useful for everyone. Other than that, I think that's it, guys. I think we're done.
One more thing I'd like to highlight is we have Babak also here with us. He really helped us a lot with organizing all of the research we were doing. And he also did some research into scientific credibility and how scientific abstracts should be thought of as credible or not. So just a shout out to Babak also, who's here. But yeah, sorry for interrupting you, Iza, please.
No worries. We are already done. Thank you so much, team. Parit, Oktay, Alex, Futse, Steve, Anmol, Christine, Vidura, Babak, Rashmi, everyone. I hope I said everyone's name. But great work. They work really hard for the project and for the presentation. And with Veronica, we witnessed everything. And I think the outcome is really good. So we would really appreciate if you can just check their, GitHub, what they did, and, like give love and support so that they can continue. They will do another project together. Yeah, they promised, right?
Absolutely.
Yeah, there's a lot to discover with different languages as well. So I think that's it, guys. That's it from us. I hope you like it. I just want to congratulate the team again here and really appreciate your efforts, your work, and what you bring to this world. We really need people like you guys. Thank you so much for being part of Omdena.
Thanks a lot.
Thank you, guys.
Thank you.
Thank you very much.
Yeah, thank you.
Mm-hmm.
Okay, I'll just stop live now. Goodbye, everyone. Take care.